Chapter 6.1 Part 2 is now going to continue on with our study of law of sines. In the previous section, 6.1, just Part 1, what we did was we worked with law of sines, and there was a certain step where we would look to see what kind of triangle it was. If it was one of our ASS triangles or SSA triangles, what we did was skip it. Now we're going to address it. So our objective here is to understand the weird Oz triangle case and the possibilities that can occur with it. So we're going to go ahead and start, and we're going to just kind of refresh ourselves through that process that we used in our 6.1 with the law of sines. So I'm going to start with a triangle. Okay, and that was step 1. We do have to use our proper labeling, which is going to be saying that those angles are going to be uppercase letters, and then we put across from them the lowercase letters that correspond to it. So I do know some of these, so I should be filling these in, 40 degrees. And then little b would be opposite of our big B, and we know that that was 10. So that was step 1. Step 2 is going to list out all that you know and put it in this kind of order where we have all of the angles in one column, so all of our uppercase letters, and all of our lowercase letters or our side lengths in the other. So I do know A, it was 40 degrees. I do know little a, it was 9, and I do know b, it was 10. So step 3 was when we would look and observe what kind of triangle this was. And you could either start at this corner and then go to the next closest thing. It would be an Oz triangle. Okay, or you could have started over here and then got a sa triangle. Okay, so I'm just going to go ahead and be blatant about it. We got that. This is where we would say stop, skip it, and move on. But now what I'm going to say is you now can go back and approach this like you would normally with this process. So I'm going to continue through this. I'm going to see that, hey, I have a full proportion or a full ratio, so I can use my law of sines. So I'm going to put the sine of my angle over its opposite side length, and then sine of B over its opposite side length. Now do note that this is a little bit different than what we are accustomed to because we are solving for an angle here. So being that we're solving for an angle, what I need you to be aware of is we're still going to solve it like normal, but we will need an inverse sign because we're trying to find an unknown angle. Right? We're trying to find this. So just like normal, we are going to use the cross products are the same with proportions. So then what I'm going to do is solve for my b, so get it by itself. That multiplication is going to have to go. So here I am going to now take the inverse sine of this side so that I can cancel out my sine. I wanted that angle. So sine inverse on this side, and we can type just this whole thing in if we wanted to. Or if you wanted to calculate this 10 times sine of 40 degrees divided by 9, go ahead, but then you would have to type in sine inverse of that whole thing. So just avoid rounding error until the very end. So when I type this into my calculator, I get the value 45.6 degrees. Okay, so 45.6 degrees. So now what I can do is I can find my C, and that would just be, again, this last angle of my triangle, which I know since they all add up to 180, I can just subtract the sum of these two numbers, and I would get 94.4 degrees. Alright, and finally to get this little c, technically I do have some rounding going on here, but that's okay. But I'm going to use my full ratio once again. That sine of 40 degrees over 9 is equal to, and then sine of 94.4 degrees. I don't have to use inverse sine this time because I'm just going for a side, but I would still do that cross multiply and divide process. And what I would get is about 13.96, but I'm just going to round that to 14. Okay, and on the test I'll specify what to round to. So just one last note, be aware that you need your mode in degrees because we are entering degrees into our calculations, so just check that and make sure. Alright, so you might be thinking, well, that was nothing. I mean, yeah, we had to solve for an angle there, but that's not a big deal. It gets worse. So we do have to recognize that this was an angle side-side, so there is a few more steps that we have to do. So the huge pain with angle side-side is that a possibility of something like this could happen. So pain number one is that A is too short to reach. So you could have an angle, a known side, and a known side, and what could happen is that the triangle actually isn't a triangle. So if this were the case, what your calculator will do is give you an error message. And if you get an error message, you're not going to freak out and think you did something wrong. You're going to recognize, oh, this was one of those angle sides, so this is a possibility, and this is what's going on, that it's not a triangle, that third side opposite of my angle was just not big enough. You're going to go ahead and write then no solution. Alright, that's not so bad. It gets worse. So big pain number two is there are two possible solutions. Two possible triangles could be built. So this is what's going on. Let's say that you had an angle, a side, and a side. And we're used to having our triangles like that. They're an acute triangle. But what could happen is that side length A is just right that it could swing in. So now what would happen is you have this triangle that fulfills that angle side-side and this triangle as well. So you have to solve for two triangles. The process that you're going to go through, and I will pause while you write this down, and you can pause to write this down. But I'm going to just keep talking. So the step that you're going to do is first solve like usual, like we did in that slide number 1. So solve like usual using the steps from 6.1 part 1. If an error does occur while you are doing this, and you recognize that it's an angle side-side, then that is going to be a no solution. But if you worked through it and you did get a triangle and you did get a solution with no errors like we just did in that first slide, then what's going to happen is you're going to have to complete the rest of this. So there's a possibility that there are two triangles, or there's just the one that you calculated. But to see if there are two triangles, what you're going to do is you're going to drop down an altitude from the vertex composed of the two known sides, and you're going to calculate the length of that altitude. I'm going to go back and do that right now. So from this triangle, I have my two sides that make up this angle C. I'm going to drop down an altitude from that. And all an altitude is, it's the height of the triangle that forms a right angle with an opposite side to a vertex. So I have created a right triangle here. So now that I have a right triangle, I can say, hey, I can use my old trig functions because I can solve for this unknown altitude. I'll call it h. Here I have my known angle 40, an opposite side, and a hypotenuse. So what I'm going to do is use sine of 40 degrees is equal to that unknown that I want, all over 10. And when I do multiply 10 to both sides to solve for my h, what I do get is 10 times sine of 40 degrees is equal to h is equal to approximately 6.43. Alright, so this is that step 4 of what we have to do when we're doing these angle side-sides. If the side opposite of the known angle is greater than the altitude, so looking across the way at this side opposite of my known angle, that's 9. And yes, it is greater than the 6.43. Okay, and then, so I just check that off, and is less than the other known side. So here we have our other known side, and a yes, it is less than it. Then you have two triangles possible. If you can kind of see this, what could happen with this A is it could swing in, okay, and what I've just created is this obtuse triangle, but it still fulfills my angle A is 40, my side little b is 10, and my side little a is 9. It still fulfills this information that I was given. So what you're going to do is you're going to have to solve for these two triangles. So if that scenario, step 4, was not true, then what you're done is you just have the one solution and you're done. Let's go ahead and contemplate this special angle side-side triangle. So again, what you're seeing is that you know this angle and you knew a side, and the idea was that this opposite side to that angle was larger than the altitude, but less than the other side known. So the idea is you could swing that in and you would be creating this inner triangle or this obtuse triangle, and there's that outer triangle. So what I want you to know is since those two red lines are congruent, because they're the same line, then our base angles are also equal. We have a geometry theorem that states that that is the case. So since this B and what we call B prime form a straight line, what we know is that they add up to 180, and B prime would just be that known B subtracted from 180. So once you get this B prime, then you could go ahead and calculate for the C prime, and you can get all the rest of the parts to this triangle. So we're going to go ahead and do that. This is the same triangle that I did in the first slide with you. Okay, so I'm just going to fill in everything that we know. Those are exactly the values that I got before. So here's that full triangle filled in. So the idea is this. There's that triangle again, but it's just bigger. What I went ahead and did was I drew in that A and I just swung it right in there. Okay. So again, what we've done is we've maintained all of these values, and we're just recognizing that there's this other triangle here. So what I want you to see is that this is going to be a 45.6 degrees, same as this. And what we need to do is we call this our B prime because this is our new B prime. There's our B that's still the same, and this is our new C prime. And this is our new little c prime. So we need to solve for this triangle right here. So there that triangle is. So start by finding that B prime. What we're going to do is we're just going to take that 180 minus that 45.6. That's going to get us now the 134.4. So you can see this triangle's taking shape. So I'm sorry, I keep starting new slides, but we got that 134.4 now. And now we can just approach like we did with the earlier process, filling in what we know. So start by finding that C prime. Now that we have two pieces or two angles of our triangle, we can get our 5.6 degrees. And then finish by just going ahead and using our law of sines like normal. So what you will see is that that is just going to get us that 1.4. So here are all our answers. Again, what we do is we just do these little notation tick marks to symbolize that, hey, this was the original triangle, this was the second triangle that we had to find because the conditions were right that there were two triangles. Our summary is, given an oblique triangle with 3 parts, and do note that we're not like the right triangles where we only needed 2 parts. These oblique triangles, we will need 3. You should be able to solve for any unknown parts so far. You're going to use that general process, slide 7, to apply the law of sines, and then now go back to your 6.1 assignment and address those Oz cases that you had skipped previously. Good luck!